Hello everyone, this is Dr. Ahmed Qusay Sabri. I am a PhD holder in AI. I am C Sharp certified. I am SQL Server certified. I am Microsoft Azure AI certified. I will give you the section about the audio classification using convolutional neural net and recursion neural net in Python. So let us dive through this. I believe the future is an audio in AI. Let me just show you the data set that I have prepared already. We have something called the positive groans. We are talking about ICU unit with patient may groans, so we can detect the patients who groans inside the ICU unit. If the patients are sleep silency, we don't care because the devices, the medical devices, take care of that. But if the patient inside the ICU is groans, so that means we need an extra alert from the AI to interfere. So we have some negative clips. It is 81 negative. If you take it, run this negative clip, negative. So no patient groans. And if you go to the positive groans, check this. So here we want to interfere as an AI. The patient inside ICU have no power to call for help. He cannot move. So what we can do, we can just try to detect if he is groans or not in order to give an extra alert to the medical staff. I would like to talk about the data set again. You have a look here. If you hover on each of these clips, you can see that it's WAV file and it's 4-second clip. Look at another file, hover WAV file, 4-second file for the positive. If you go back and check the negative, also the same process. Hover, wave file with 4 seconds. So these files have been well prepared actually. I prepared this file carefully. But we have one tiny problem. Look at the number or count of the files. In the positive, there is 59. In the negative, there is 81. It's not balanced. There is a gap. It's not a big gap, but there is a gap. You need to handle that. Plus, if you can get more files, 81 and 59 is not enough. I am just a training aspects. It's not enough for the real model deployment. Also, I create a prediction eclipse. It's empty for now. Why? I will feed the CNN and the RNN with the positive groans and negative groans folders for the sake of the training. And at the end, after the training process, I will test the model with the prediction eclipse. So let me take 5 eclipse from the positive, Control X cut. So Control X and go to the prediction eclipse, Control V. So we will hide this eclipse from the original model. Also go to the negative, take the first 5, Control X, and move them to the prediction eclipse, Control V. So here in the prediction eclipse, we have 10 eclipse, which is not shown to the neural net at all. When we finish the training phase, we're going to test our neural net with these clips. So this is the process to make yourself convenient with your model. We can get, of course, we can get accuracy parameters from the Python, but if you want to convince yourself, hide some clips, and after that test the model with these clips. So actually, we're gonna feed the neural net with these 2 files, with these 2 folders only. Again, I would like to say something about the count balance. We have 54, 54 positive, and we have, for the negative, we have 76. I will delete some files from the negative for the sake of balancing. So 10 files will be deleted. So now we have 66 in the negative, and in the positive we have 54. Just 10 clips gap, it's okay, no problem for that. Now we have prepared our dataset. You can download this dataset and use it. uh, it's my own dataset I have created from A to Z, so you can use it for your training. I will go to the account, my account in the collab here, as you see here, and I will create a folder, and not in the collab actually, this is the Google Drive. I will create a folder and call it CNN underscore RNN audio Groans. This is our folder. Here is our folder, and I will drag and drop my dataset inside this. So this is the dataset, and I will drag and drop it inside the folder. I'm gonna just wait until I will freeze until the dataset is uploaded. Pause. Okay, as you see here, all the dataset have been uploaded to my Google Drive. I have the dataset, and this is the project folder. Quickly, I will create our Python file. So right-click, More, and Google Colab. This is actually our coding collab file. First step, we need to do some kind of text all the time. So try to give the heading of your project. So it is CNN, RNN audio detection and classification, whatever you name it. And also we need to specify which kind of data. It is actually the Groans for patients of the ICU. Also, we need to specify some July 2025. That's very good. And also at the end, you have to specify the closing date of the project. And of course, my name, program manager of the project. That will be good. Okay. Also, we need another text, which is for section 1. Please divide your file into sections so that you can minimize and maximize, hide unrequired sections. So this will be section 1. Section 1 will talk about the Dataset Connection, the libraries. So actually, this is the core of Control MB. So now we have to create our first programming. We don't need this one, so we can delete it. I have just created the section, and the first part will be connect to data set. So it will be like this. Go to this folder, sign and connect to your drive. We already upload our clips, so please go for mount drive. Yes, I want to mount my drive. Connect to Google Drive. I'm waiting the drive to appear here in the left panel, which is the files in Collab. Yeah, now it's appear. If you just take the details, here is our project. Actually, we need all the paths here. As you see here, this is the data set. So I will bring the entire project link. So copy path. So this is the project path. Why I need it, I will tell you now. First step, you need to do Control MB and go for %cd Control V. So I will change the directory to the project path, Control Enter. So now we have changed our directory, default directory, to the project path. Why I am doing this, I will tell you why. Control MB. Now we can say percent ls, control enter. Look, this is our directory, dataset, and an empty Python file, collab. In the future, when you want to save your model, it will be automatically saved in the default folder, which is this one. I changed the default folder to this one instead of drive. So this is why I am changing the default directory. So you don't need, if you save your model in the future, you don't need to search for the model where it has been saved. No, you know exactly from the beginning where it will be saved. And most of the time, actually, we are saving our model several times until we get the best performance accuracy for our project. Now bring me the data set, the negative and positive. This is the negative. So bring me the path, copy path. Control MB and negative path is this, and the positive, just keep it because you'll need it several times maybe in your project. Path is this, copy the positive path. Positive path, this one, copy. Control V, have a look. Everything negative is on the negative, correct. Positive is in the correct. Everything seemed to be fine till now. So now we need also to connect our data set to the control MB. So we don't need the left panel anymore. If you need it, you can retrieve it again. So this is our data set is here. So I will say, I will call it TS underscore audio underscore file. Look, I'm getting help from AI because I'm regularly doing this. So I will press tab. Don't trust the AI coding. Just you need to do it manually. Look, it's help, just help. Okay. Yes, audio files path. No need for path. Just I need to name it as it is. Yes, audio files. No audio files, correct. Yes, it's correct. Check, I will use something called glob. So we need to import some libraries here, control MB. We will say from glob import glob. From glob import glob, control enter. A glob actually and OS, we can say also import OS. These two libraries is helping me for directory, play with the files, paths, something like this. So I will use actually this glob for the sake of, so I will say glob, open a bracket, and close a bracket. I think we recommend single quotation, home, go back, and also single quotation. This is actually how it works. But you need to specify, check the files, content drive, my drive. You say yes, so that means it's a positive correctly. Now go and add backslash star all eclipse dot WAV. Clear? Also, you need to do the same for the negative files. So I will say glob, open a bracket, single quotation, move to end, single quotation, close a bracket. I get some help, but I didn't use it. Backslash star dot WAV, tab. Cool, control enter. Everything is fine. Now check your files, control MB. I will say comment, LEN, help me, AI, thank you, tab, control enter. I have 54 files by 66. But please, when you print something like this, print it accurately. How we can do that? We will say positive, because it's yes, comma, then here also, double quotation, comma. It will be better as a layout. We have positive 54, negative 66. We have done with the connection of our data set. We have done with importing some required libraries. Move next, which is actually play the audio and using of Librosa. let us start. Okay, so we finish with connecting to the dataset, and now it's the time to go for section two. All the time, I advise you to create your program in sections, split your program in sections. So section two will be actually for uh, four stages of audio process. We need to process our audio files, control MB. This is the first cell, and we need here, we create the data set. We already have two folders, two different data sets, the positive and negative. We will combine them together to create our own data set. I think we will start import some libraries like import librosa. Yes. Yes, I get some help like matplotlib, TensorFlow. I think we need to import something called I. Yes, IPython.display as IPD. This is helping me to play the audio. So I need to play the audio to see what is going on. Control Enter. Now I will combine these two groups of clips into single list. Control and B, create our data set. Any help? No. So audio underscore files equal. Thank you. Yes, audio files plus no audio files. Control Enter. Control MB. Check the LEN. Any help? Tab. Thank you. Control Enter. We have 120 Eclipse. Control MB. We need to print all or print data set. Print data set. Any help? Yeah, it's the audio file, but actually I will do the following. I will go for a for loop, starting with a counter equals 0. Thank you. Tab. For I in audio files, so please print the counter. No, I want the counter is the print after the file itself. I'm printing our dataset actually after combining positive and negative together to see what is going on. So this is actually the files that we have combined. Don't forget we have bring the yes audio file first. So the positive is coming first. How many positive file we have? 54. From the previous work, we have 54 positive. So from 0 index to 53, from 0 to 53 index are considered what? Positive. The first negative file is index 54. You need to really understand what is going on in your dataset. So let us play this audio to Control and B, and I will say play audio to take some help from AI. Thank you, Tab. You see, uh, IPD is IPython display library that we had already imported a few seconds ago. Control Enter. So it's file 0. That's mean it's positive. Run. Last positive one is index 53. Is that right? It should be last positive one. Play. First negative file is 54. Run. Negative. My data is working properly. I would like also to say something. Go home and say x equal to save our clip in X. Control Enter. Give me control the type of X. Thank you. Control Enter. It's audio. Cannot feed to the neural net. This is why we are going to using Librosa. Okay, thank you, Librosa team. Control MB. So load audio. Thank you. When you load audio using Librosa, the good news is that you're going to get two outputs from the loading process. So it's librosa.load, and you can load any one of your files. You get Y, which is the audio itself. I just rename, and the sample rate. So if you get the audio in the shape of array that we are looking for. Control enter, control MB, and give me the type. Thank you, ND array. This is what I would like to use to feed the neural net. If you go back to the IPD, which is IPython display, it is all the time give you some type of audio, cannot feed to neural net. While if you use the librosa.load, you get the audio in format of array. This is what you want to use. What we can do more, we will control MB, we will see the shape of our array. Tab, control enter. It is one dimension array, so in the future we need to expand. Control MB, please plot. Thank you. Tab, control enter. So this is actually the raw called it's called time domain audio. The neural net cannot extract features inside of this simple shape of data. So for this purpose, we need the 4 stages to convert this time domain audio into another shape. So this is why we are talking about 4 stages. Stage 1 actually already done, which is the loading. So this is actually stage 1. Stage 2 for the processing of the audio, because this is not enough to the neural net to extract features. We need to use or apply something called short time Fourier transform on the audio. So also using Librosa, thank you Librosa, from audio. Don't forget this is stage number 2. From the original audio, we will apply a Fourier transform and we will get something called, officially, scientifically, it's called Frick 1C domain audio. This is the official name after you apply Fourier transform. So now we have applied Fourier transform, which is the second stage. The third stage actually is the decibel. Convert our audio to decibel. Tab, and we get the help of AI. We will convert the frequency domain obtained from stage 2 into something called decibel in order to finalize the process. But here we need to go for some extra activities. I think this is numpy.abs, and here we need also comma, escape, ref, tab equal mp dot max. Everything is fine. Yes, control enter. So now we have done with stage 3. We still have only one stage to finalize all the process. But let me before go to the final stage, I would like to say something. This is called the spectrogram after we convert to decibel. So let me plot control MB and plot enter. Thank you. Control enter. So if you see here, actually we have done this is the end of transforming the original audio into this shape. Now there is a lot of details the neural net can look and extracting the features when you want to detect some audio inside your clip. So this is the end of the journey. Actually, we still have only one stage, control MB, which is we need to check the shape of the data. Tab, control enter. It's 2-dimension. It's not working because the neural net need a 3D. So we have to expand DIMS, enter. Thank you, tab. We will expand our dimension from 2D to 3D. So this is disable audio or the final stage, which is stage 4. Actually, this is the stage 4. This is the last stage. After that, we can go to the deep learning part. But I will use TensorFlow rather than NumPy, TF, for the sake of programming. Also, the -1 here access mean the last new column. So this is index 0, index 1, and this is the new column to be inserted for the expansion of the dimension. You can change it instead of -1, mean the last new one. You can put 2, referring that index 0, index 1. So put the new column at index 2. It's okay. This is for understanding what is going on. Check the shape again, Control MB. I will check the shape. Thank you, Control Enter. Done. All done with the requirements. What we will do now, these 4 stages must be applied to all the clips. I was just testing one clip for the 4 stages. So let's do it, Control MB, and I will just say generate audio files, enter. First of all, I will create a list, empty list, to save all my processed audio. And actually, where is the entire files? Where are my files, original files? Actually, it's here. If you remember, we combine them in something called audio files. So I will use for loop. For, yes, thank you. For I in audio files, I will say for I in actually range, open bracket, 0, comma, len of the audio files. This is like some processing of the coding. I know it's important. And stage 1, if you remember, we will load. In stage 2, we're gonna STFT, short time Fourier transform. Here we're gonna applying the, I think we miss close the brackets. Yes, sorry. Now it's okay. After the loading, get help. Thank you. So the 4 stages: load, Fourier, disable. Audio, we are getting our load from the, but here it should be not I, while it's audio file of I, audio files of I. Am I right? Control V and square bracket of I. Correct. Then after loading, go to the audio and convert into frequency domain. Totally correct. The frequency domain should be converted into decibel. All fine. After that, we can just easily say data dot append. Yes, and we need to append the final destination, which is the decibel audio file. Any help? No, we can copy this and Control C, Control V. That's it. These are the 3 stages, and actually the expand of dimension, I will choose. I will put it as a separate stage. Control Enter. It will take some time. I will pause. Oh, it's quickly run. So now we have all our because actually I am using my Pro account. I purchased an account for, if you see to the runtime, change runtime, I'm using the, it's very wrong. This is why it's slightly, I cannot change now because it's, I don't want to disable, but I should use this. I'm paying $10 per month for them. I forget to change the runtime type at the beginning of the session. So now we have done with the processes. Need only expand the dimension, which is the last stage in our process. So Control MB, and I will create something called like audio clips processed. The processed audio clips, which is an empty and I will insert all my expand dimension clips inside this. So 4 and range length of data. Okay, so we are expanding the dimension. Expand dimension, okay, and use TensorFlow rather than NumPy. Check the code if it's correct or not. From I range of length of data, correct, because our data is saved here. Audio clips process.append, correct. TensorFlow expandums, I think it's all fine. And we want to add the new dimension at the end of the last dimension. Control Enter. All fine. We have done with the preparation of our data. See you in stage or section 3. Moving forward to section 3, we will discuss the anomaly of shapes, if any, and we will discuss the labeling of clips. Okay, normally, if you want to print the shape of any of the audio, we're supposed to have something like this. Thank you, AI. We suppose and assume all our processed clips should have this shape permanently. It is not negotiable. Why? Because if there is any of the clips does not have this shape, I will get error in the future in the neural net. Neural net does not accept different shapes, especially the CNN. It need a fixed shape files. So this is a proactive procedure, and it's a mystery error when you dive through the neural net and get some error which is unsolvable actually. Let us check all our clips shapes. Print all audio shape. Any help? So I will go for the counter equals 0 for I in range 0 to len of the, thank you. Now I get some help at the end after. So please review the help from AI. We are scanning all our processed clips and print the shape strictly with the counter so that I can see. Let me run Control Enter. Now, if there is any anomaly shape, I can, from the index, delete it. Scan it by your simple eye, or you can write a program from function, Python function, to do it for you. I will scan it quickly. If there is any anomaly shape, yes, we have one here. It is with index 57. So go and delete it. Hide. Index 57, that means after index 54. From index 54 and to the end of the clips are negative. So I lose one negative click. It's okay, no problem. So Control and B, delete. So DEL audio processed clips with index of 57. Control Enter. Deleted. Repeat this loop again. I will run it again. We suppose and we assume 57 has been removed. Yes, no more 57. You can scan the remaining of the clips. Everything look be perfect. So please, this is called the anomaly detection of shape. This is crucial. Now we can move to the labeling process. Okay, labeling. Print audio, please. Print one of the audio files. So audio 57, it's okay. That we have already worked on, or 0 or whatever. Control Enter. I have a question regarding to the labeling. Can you tell me whether this array, I am talking precisely, this matrix is a negative or positive? Take your time. Actually, we cannot answer this question. We don't have evidence whether it's negative or positive. But from the name of the file, we know that index 0 is positive because we create our positive data set before the negative. But the neural net does not look at the name of the file. It looks at the content, not the name. So there is no label in the array reflecting whether it's positive or negative. So
we will add the label at the end of the file. So this is a positive file because we know that. So we will add sticker with value of 1. This is called labeling. TensorFlow, actually, thank you, TensorFlow people, do it for us and help us to do that. They call it tensor slice. So first of all, let me generate labels tab. No, leave it. Generate label. I will not take this code. I want to write my own code. I'm a programmer. Don't lie on AI all the time. We need to discuss first. How many positive you have? We have, before the positive, what is the total number of clips, length, LEN, of audio control enter. Total you have 119. Good. Control MB. How many positive you have? Actually, for the positive, we have from index 0 to index 53. So we have 54 clip. For the negative, actually, it is as follows. 119 minus 54. Is that right? Yes, right. Control enter. So we have 65 negative. Who is first? The positive. So generate labels of values of ones before labels of values of zeros. So this is how it works. Actually, I am just discussing myself with you. Control MB. So actually, we will use NumPy. Thank you, NumPy people. Labels of 0 equal mp dot, not comma, dot zeros. Yes. How many zeros you need for negative? For negative, we said that 65. So 65. So I will generate 65 label of 0. Labels. I need to correct the spelling. Labels of NumPy. Okay. What about the positive? The positive will be, yeah, thank you, AI. Labels of ones of 54. Is that correct? I think yes, that is correct. And finally, we can combine them together with labels 0, 1 equal thank you, tab, NumPy concatenate. So this is how it works. Be careful. The positive ones before the negative 0. So Control X and give me the Control V, comma. Don't forget to put something called access equal 0. Control Enter. Everything is fine. Let me print the label 01, labels 01, Control Enter. Now we have start with the ones followed by the zeros. Let me make final check for the length of labels and clips to get matching of them. Length of labels 01, correct. No, I will not make it. Okay, print, it's better. Print, open brackets, labels, comma, end, and close brackets. Same for Control V, not labels, but audio clips. And here instead of labels, we will go and say audio processed. Control Enter. Cool. 119 label, 119 clip. Go and add each label to its corresponding clip using TensorFlow. Okay, I will say Control MB, tensor data set, enter. So tab. No, not like this. Sorry. Thank you. So tensor underscore data set equal tf dot data dot data set dot from, sorry, not space, from thank you, tensor slices. Now you need to open brackets. Give me the audio clips comma labels, tab, and I will do it for you. TensorFlow, thank you, TensorFlow. We'll add each label to its corresponding Eclipse. Control Enter. It's done. I need to print and make sure my work is working perfectly. Print tensor data. No help, no problem. So counter equals 0. Sorry, 0 for I in range 0 to the len of tensor. Yes, yes, yes. Now I get help. Okay, after half hour, no problem. So print correct. I want to print the tensor data with the counter to see what is going on. But actually, I want to print a specific tensor, not all. If count, yeah, yeah. Okay, move this to the end. Control X. I will tell you what I'm doing just for a while. Okay, Control V, and let the we need to add some indent here. This is why there's an objection. Okay, let me show you the first tensor. It has a new name, tensor. Why? Because it is the audio with the label, with the sticker of 0 or 1. So let me print the first tensor. It's supposed to be positive. Control Enter. We have an error. Let me check. I'm sorry, we don't to need, it's not for, it is for I in, so it's only I, no need to bring the array name. So I, Control Enter. And also no need to in range, so just in tensor dataset only. Tensor dataset, yes, tab, Control Enter. So now we have the audio, this is the audio clip, and it has attached to the one. This is the label. So this is a positive array. This is the audio, and this is the label. Thank you, TensorFlow, helping us to do so. It's not easy process if you do it manually. Let me check count tensor number. Last positive one is actually 53. Control Enter. Positive, thank you. First negative one is count is tensor 54. It should be negative. Control Enter. So we should have 0 index. That's perfect. So we are doing our work perfectly. Now, this tensor dataset generate one batch of data. It's not recommended. I will give you a short example. If you allow 1,000 persons to leave a tower in small gate, it will be crowded and there will be a crash. This is what will happen in your neural net in the future if you allow one batch. So please split your dataset into batches. This is what we will do now. Proactive programming. I will copy this code, Control A, Control C, Control MB, and Control V, but tensor dataset with batches. All what you need to do, go to the end and say dot batch and give it like 2 batches. How can it work? Rename the tensor dataset into underscore with batches, with 2 batches as you like. That's it. Control Enter. So what is happening now? I will copy the counter also. Control A, Control Copy, Control MB, Control V. I will not print the tensor dataset with 1 batch. No, I'm gonna do it with the 2 batches to see what is going on. So print. I want first to print the length. Control MB, give me the length so we can realize what is going on. Thank you. Control Enter. 60. The old batch is 119, which is approximately, this is since 2 batches, so it's the half. So each batch contain 2 audios together, 119. So this is why we are splitting our dataset into two batches. So that means counter 54, which is index 54, contains two clips. Let us check. This is the first one. And if you look here, we have three closed square brackets. This is the closed end of the first audio in the batch because each batch has two audios. And this is the second audio in batch 54. Go down, we have two labels. And since it's the 54, so that means both are negative. If you go to batch 0, both are positive. So we have two clips here, starting from this, the end of the first clip, starting of the second clip, in batch number 0, going down, both 0 batch, 0 index, zero tensor, both are positive. So we're supposed to have two ones positive. The first one for the first clip and the second one for the second clip. Final decision we need to make on data. Since we add labels to each clip, why you are sorting them positive first, then negative? Why you keep sort of data? Now we have labels. Shuffle the data, mix the data, blend the data. This is better for the neural net. Don't make them in sequence or a serial or in a fixed sequence, positive, they're negative. No, 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 no. Blend your data. How can we do that? This is the final stage, is blending our data, and it's called shuffling. I will take the copy of this data, which is already with two batches, and control MB, control V. I will set with batches and shuffle, mix, blend. Go to the end and say dot shuffle. It's here. Thank you, TensorFlow. Go and change the name, two batches underscore shuffle. No need to keep it positive then negative. Shuffle. Now we have already assigned labels. Control enter. I'm getting faster results, by the way, because I'm using my pro account. Check the length. Control MB. There is no change in length. The batches are still two, so the length is kept as it is, but mix. LEN. No need to check the length. I think yes. I think no need. It's control copy, control V, control enter. Shuffle length. What is the problem? Actually, I forget to put the shuffle argument here. I'm sorry. Normally 1100 as you like. Control enter. Now check. It's 60. There is no change because two batches. It's still two batches, but shuffled. Go to bring this counter to see what is going on. There is no more positive first, then negative. No, no, no. You can find a mix, positive in index 0, negative index 1, 55 is index. It was negative, now maybe it will be positive. So control copy. I want to check what is going on. Control MB, control V, change to the alt, control Z. So give me this, control V, again, copy, control V, yes, control enter. So index 0, it's supposed to be, in the old days, previously, it's supposed to be positive. Maybe it's still positive or negative. I don't know, actually, we need to check. Instead of positive, it become negative. This is index 0. We have done everything related to the data has been prepared. Sorry, little long video, but I hope it is useful. Next section, section 4, we're gonna dive through the deep learning. Thank you. Okay, it's section 4. It is the starting of the deep learning. So we will start with CNN, convolutional, and neural net. In section 4, for audio classification. In section 5, we're going to cover the recursion in neural net for audio classification and compare the CNN with RNN. From our audio processing, pre-processing of dataset, we have reached the tensor dataset with batches underscore shuffle. So this is our latest processed audios. So let me first step, we need to split between a train and test of dataset. So train and test data set enter. Maybe there is some help. I will go for a train equal, give me the variable name dot take. I will take something and skip something. Enter for the test. It will be equal to control V dot skip something and take something. Okay, the total amount, the length of tensor dataset with batches underscore shuffle is 60. So 60 tensor. I will take 5, 7 tensor for training, and then I will skip for testing. I will skip what I have been take for training. I will skip them and take the remaining 3. So and take 3 for testing. So this become the total of 60, 57 for train and 3 for test. This is how it works. Remember, each tensor consists of 2 clips. So 57 multiplied by 2, it will be 114 clips for training. 3 multiplied by 2, it will be 6 for testing. If you have more data, it will be better. Control enter. So now we have split our data into train and test. Control and B. I think it's the time for Kira's libraries. Enter. If there is any help, I will be appreciated from tab. This is the required libraries. Mostly it is the required help supported by the AI. Control enter. So I have obtained the required library approximately. You can check them if you say you need more. And I think it's the time to create Kira's model. Tab. So this is actually the start of the model. I call it model. Model equals sequential. I think I will scan the layers, but I will not dive through the mathematical aspects of each of these layers because actually it is like an audio classification rather than being a neural net explanation. So I will start with model.add. I need to add layers one by one. So I will set on yes, tab. Thank you. So this is the first layer. You can play with these numbers all the time. These numbers, I will go for 663 reload. It's very brilliant with the non-output layer. And all the time, this is an input layer, so we have to support the shape. What is the shape of our audios? Actually, if you remember, we fight to obtain this shape previously. So our shape is actually exactly like this. This is our shape for all audios we have prepared previously. So 1025, 1731. So delete, it's 1025, comma 173, comma 1. So this should be mentioned only in the input layer. Go and give me like model dot add. I will go for max help. Thank you. So max pooling 2D. This is very important to reduce the size of the model at the end. You cannot upload the model with more than 1 giga size in Raspberry Pi 5, for example. So please control the size of the model. Again, you can play with these numbers. I think you need to add the drop model dot add. It's the time to add drop out, not help. Thank you. 0.5 is slightly high. I will go for 0.2. So this is layer number 1, and I will copy it, Control V. But you need this Since it's layer number 2, you should remove the input shape to indicate that this is not layer number 1. So this is how it's worked. I think it's the time to add, you can play with these argument tab. I'm using the AI for help. So flatten, it's the time to flatten after you finish your convolutional layers. After that, flatten. After that, this is actually an ANN. This is not CNN. This is normal, fully connected neural net, ANN. So also you can play with these values. This is the output layer. As you see here, we have sigmoid function at the output layer. Now I think you can, and here it should be 1. You cannot play with this value because we have a binary classification, negative, positive. Control enter. It's working properly with the warning. No issue with warning. It's okay. We are fully convenient with warnings. Now it's the time to compile the model. Compile. Any help? Thank you. Tab. Check the our optimizer is Adam. Perfect. Binary cross entropy. This is a must. Why? Because we have a binary classification, negative, positive, and this is the matrices for the accuracy. Control enter. I think it's the time to go for summary. Please, model summary. Model summary. It will be very important. Yes, thank you, AI. Control enter. Look at, this is the arguments. Look at the size. It's relatively small size model. It's not easy. It's relatively, there is a lot of parameters, arguments, but the size is still under control. Small size. Why? Actually, the reason of why it's a good size because of the max pooling layer. It's very effective when you want to minimize the size of your neural net. Control MB, and now I think it's the time to go for fit your model. So model fit or fit model, whatever you can call it. So we will go for model.fit. Any help? No help from AI, no problem. So thank you. Train, epochs, validation. So I will normally start with 2 epochs because if your model passed the first 2 epochs correctly, so he can pass 100, 2,000, 100,000 epochs. So please all the time test the first 2 epochs slightly. And I recommended, it's very, very recommended to save your training model in something called, normally the programmers convenience use something called HIST, referring to the history of the model. Control enter. It should be faster training. Why? Because I am using my pro account with the runtime is GPU actually, as you see here. Thank you, Google, again. So since my model passing the first 2 epochs correctly, so that's an indicator, go for 20, control enter. I will freeze for a while. All done with our model. This is the training model. As you see here, the accuracy is 1 and the loss is very, very, very small value. This is actually our target, and the same reflection with val accuracy and val loss. It's the time to, I would like to just control MB to see the history keys. I'm talking up, yeah, thank you. Chap, I'm talking about how we can measure the performance of our model because we already saved in the HIST variable. Control enter. We have accuracy, 4 arguments help you to measure the performance of your model. Loss, val accuracy, val loss. So let me just plot control MB. I will plot the accuracy. Sorry. Plot accuracy. Tab. So you see AI is helping because I'm using the same all the time, the same programming aspects. Control enter. Look, since the 2 curves are working together, plotting together, relatively close to each other, no one under, no one over, underfitting, overfitting, since they are on the same trend, you are on the safe side. I can go and give it a chance for another like another 10 or 20 of fitting. Go, give me another 20 fitting. Maybe the plot will be enhanced. Maybe, huh? It's fast because I am using Google GPU account. Again, I will plot for the relatively better, and so on. So you can all the time go for more training. Control and B. I will plot the loss. Tab. Control Enter. The loss is supposed to be something going down, going down. I'm plotting val loss and the loss. Actually, it's not so convenient, but it is going down. So you can do what? You can go back to the training and make another fitting of your model, and so on until you get the better performance of model. But remember, we have only like 120 eclipse and it's audio, so maybe you will not all the time get what is you're looking for. Try another plot for the accuracy and try another plot for the, yeah. So this is like, this is what is the performance maybe appear. Give it another chance for, um, I will do one thing. I will load the model again. Look, I will load the model again, go for compile again, go for summary again, and I will go for 30 epoch. All the time you need to practice training until you get what you're looking for. I will freeze. All done. I will try to plot for better performance, for the accuracy. Yeah, now it's better. You see? Now it's really better. This is really impressive. You try all the time, please. So this is how it works actually. Also for the loss, this is the old loss that we got. And now let me check. Brilliant. This is a brilliant loss because we are all the time looking to minimize the loss all the time. It's tight or coherent to zero. So you can be happy for this kind of plotting when you obtained. Move next. Actually, the next step will be the saving the model. I like it. So now it's the time to save. If you are not convenient, don't save. Did you see me? I tried several times until I reach what I am looking for. So we will start saving our model. First of all, to save your model, you need to specify the location. Where is the default location? If you remember, we talked about this at the beginning. So percent cd ls, sorry, not cd, ls, control enter. So this is our default location. This is our default location. There is already a previous model, so I can go to this. This is our default location, that where we save. I will delete this model. Delete. I don't want it. Okay, and now go for and run ls. This is our content of the default location. Check where is that, my drive. Here is the location of the, or the default location that we will save. So it's dataset, two items, the dataset and the Python file. By the way, I just forget to give the name to the Python file. This is not good, actually. You should give it a proper name from the beginning, no problem. Okay, so when you create or save your model, it should be appear here. So how can we save it? So I will put a comment, try to get help, save the model. Any help? Yeah, thank you. So we get model.save and it gives it a name, CNN audio underscore groans.h5. I strongly recommend to use the extension of h5 when saving a neural net. I'm talking about a neural net only. If you are going to SVM, base, the extension will be different. But here I'm recommending to use h5. Control Enter. So it will take some time to save the model, but it should be appear here. Ah, it's appeared, you see? So this is our model. Actually, it's supposed to be take more time, but I'm using my GPU. And look at the location itself. I will refresh. So the model is appeared. Look at the size, 244 mega, quarter of giga. It's not a small size, it's a big size. So now we have saved our model. Remember, we save our model when we like it, not the first model that we obtained, we saved. Time to make a new prediction. So I will go for a new prediction. I like my model. I will go for a new prediction. But before that, let me go to the drive. This is the project location. We have dataset. We have something called prediction clips. We hide these clips from the neural net training. So there is no neural net saw these clips before. So we will test our model here. I will test with this and this as a diversity of positive one and negative one. But you should test the model with all of what you hide in the beginning of the process. So let me just first bring the control. I will load audio from the hidden. So I will call it negative underscore yes, negative new audio path, yes, equal help please, no problem, glob, open brackets, close brackets, and the same it will be for positive, yes, equal globe. So we will actually bring two new clips. One, we call it negative new audio path, because new, it does not train before. So give me the path. This is the data set, and this is our folder which is not been seen before. I'm waiting. So we get the prediction eclipse and the new eclipse never seen before by the neural net. Give me one negative. So this is the negative one. Copy path and single quotation and control V. Okay, and for the positive one also, copy path, single quotation here, control V. You need to inspect what you have done till now. Check it. This is a negative, correct? And the path reflect you a negative file. Okay, and this is a positive, correct? Yes, and the path reflect you a positive file. So we have two samples for prediction, control enter. Now these two samples actually need to be processed with the four stages audio processing, because all our data have been processed for 4 stages. So we have to feed, when you want to predict in your model, in your saved model, when you want to feed, it should be also processed audio. So we need to load using Librosa, convert using Fourier, convert to disable, and expand our dimension. So let us do it quickly. We will generate data, empty data equal. So this is our list for our data. So now we're gonna for I in range 0, 1. Why 0 to 1? Because we have only one prediction file, to be predicted. Okay, so we will first load from you or using Librosa. Thank you. Tab. Okay, so positive audio. Okay, we're gonna bring the positive one or the negative one. Okay, let me give the negative one first. Control V. I get help at the end from the AI after STFM check. So audio. Okay, audio is here, correct. Frequency, okay. And the next step is the decibel, right? Convert to decibel. Thank you. Tab. Check frequency, ref, okay, 2 decibel, okay. The generated audio will be decibel audio, correct. Finally, you can append, control enter. So actually this is called decibel audio. Let me check the shape of this, control NV. shape data z. Okay, control enter. It's two dimensions, so we need to expand the dimension at this point. Control MB, expand dims. Any help? Tab. Check. So we will generate a new audio clips processed, okay, using length of data. I don't think it's length of data because it's one clip, so 0 to 1. No need to the length of data. Okay. I think everything is going smoothly because we want to expand and add the new dimension at the end. Control enter. Check the shape again. Yes, it is the processed clip, expanded dimension. Not this one, sorry. Cool. So we have expand dimension. So we are ready to go for tensor dataset. We have expand dimension, but tensor dataset. Enter. Any help? Thank you. So tensor dataset should be on this. Audio clips processed. And don't forget that we are doing two batches. So O dot batch of 2. This is exactly what we have done with all previous clips. So when you make a new prediction, you have to do it again. So now we get the tensor data that we can use it for the prediction. Control MB. No need to shuffle because it's only one clip. And I think it's the now to load the saved model. Thank you. Okay, but I think there is some, okay, I will try this and save the prediction or print the prediction. Before I run this, this is correct save model. Yes, we can check. This is the name. The name is here. CNN audio groans.h5, CNN audio groans, okay, okay. Which model, which clip we will, it is the negative, right? Yes, because we have processed with the negative. So it's supposed to be 0 or close to 0. Run. Model matrix will empty. I can simplify the suggested code. I will say the from yes, import load model, and the model will be only quickly just load model without extra libraries required. I'm just simplifying the code from my experience, you know, to get the results. So this is why you need to be expert. We still don't have Kira's models from Kira's import load model. I think there is no issue with these messages. I think, yani, inshallah, hopefully. Let me move to the prediction. This is the challenge time. Control MB, and I will make a prediction. This warnings is all the time appear, but mostly it does not have any like backdrop or problem. Tab and print the prediction. Make sure that the model is the same name and it is okay. Moment of challenge, run. Cool, it's 0.0, so it's a negative. It's a negative. Let me test the positive one. This one is a positive. Control copy, put it here. Control V, run for processing the positive. Check the shape, it's okay. Expand, check the shape again, it's okay. Go for tensor, is okay. Load your saved model, it's okay. It should be 1 or less. It's positive. Run. All fine. Thank you for CNN, and we have done. See you next section, which is the RNN for audio classification. Thank you. Okay, it's the time for section 5, which is the RNN for audio classification, the recurrent neural net. I will use the LSTM type of the recurrent neural net. What I will do in this section, actually, I will copy the entire CNN section. So this is our entire CNN section that we have obtained a brilliant result, actually. I would just click on this section, minimize and click, then go here, copy cell. We got a message here down, copy 21 cells. I will do nothing, just control V. So now we have pasted uh, the uh, the new cells here, so we get like two copies of the of section 4. This is the original section 4, as you see here, and this is the copied one. That's better because we are moving in the same sequence for RNN as we have done previously in CNN. I'm talking about sequence of operations, but the content will be definitely different. So I will change the name. Instead of section 4 CNN, it will be section 5 RNN. So this is the first step that we should go for. Split our tensor data into train and test, so we don't need to change anything here. So we will follow and obey the same sequence of RNN. But here we're gonna change, instead of CNN libraries, we're gonna import the RNN libraries. Actually, RNN is from Keras. By the way, I forgot to give my thanks to Keras. Thank you, Kiras, for all what you have done to us as researchers, programmers, AI developers. Thank you, Kiras. So I will say LSTM. This is a must. Max pooling, we don't need it because it's not no more CNN. Keep flatten, keep dense, keep the other aspects. So no need for new knowledge. We are using Keras all the time. Control Enter, we have done with imported, but here I will say actually Keras libraries. I cannot say CNN, RNN all the time. I'm a Keras person, like by means of loyalty. Okay, here also Keras model, I will say RNN for distinguish. We're gonna like keep this sequential. We don't have an option, and we will start change model at instead of convid. I will delete that and say LSTM tab. I get some help from the AI generated uh, from Collab. Thank you. And this is actually, there's a big difference here between CNN and RNN. And in CNN, we are feeding with the 3D in 1025173,1. But here is the distinguished difference, a pillar difference here. You need only to submit this shape to the RNN. This is why there is some kind of change. Also, we forgot to put the activation. Yes. Look, the most commonly used functions in RNN are tan and sigmoid, while the most commonly used function in CNN are relu and sigmoid. So this is also a difference. So I will use tanh as an activation function rather than using relu in CNN. We don't have to add any max pooling here, but I think I will keep the drops as is. I'm playing with the topology of CNN and convert it into RNN. So this is for easy way. I will, instead of adding a convolutional model, I will add an ST layer. Sorry, instead of adding convid or convolutional layer, I will add LSTM layer. Shift and Control copy. I think there is an error here. I will check it. And I will copy and paste this new layer, but you need all the time to remove the input shape and put it strictly on the input layer. So no need to specify the shape again. The shape should be specified once only in the input layer. Let me check what is the error here. I think I have more than one error. It's a matter of square brackets, maybe. Okay, there is a comma here. Sorry. Now everything is perfect. I will add another dropout, copy. So remove this max pooling. I will keep the dropout. If you like, we can add another layer. No problem with that. You can add it. Control copy. So we have like 3 layers. You can play with these values. I will set, instead of 128, I will set 300, as you like. It's You can play with these values, tuning values. Tuning means you need to set up the correct combination of these values until you get the proper performance. 300, 300, and 300 unit or neurons, you name it. And that's it. Don't forget to put the flatten. No need for this dense layer anymore. And we have the output layer only. And all the time it is an activation with sigmoid. Don't play with this unit value because we have binary classification, so it should be 1 unit or 1 neuron in the output layer. So this is our output layer. I think we already control inta. Everything is going fine and we get the correct sign. Come here to the compile. Is there any change here? Adams binary accuracy. There is no change. It's the same as compile of CNN. Now, also the summary will be the same. We don't have any change. All the time, please monitor the size of the model. Again, we're gonna fit. We don't have any change because the train data is already the audio files and the test data is the audio files that we have hide. And all the time we start with 2 epochs. When it passed 2 epochs, that means you can go for 30, 100, 2000 epochs. It depends on, but just pass the mathematical aspects with 2 epochs. It's LSTM. Slightly take more time. You see the difference between processing of the CNN. If you go back to the CNN video and the RNN, slightly RNN is consuming more time. So now I'm ready to go for like 30 epoch. So 30, control enter. But actually, you look at the time process. Even I'm using my pro account. I'm using the runtime of GPU, but nevertheless, as you see here, the speed is slower than the progress of CNN. I will pause for a while. Okay, I am in the 27th, 28th epoch. As you see, the loss is still high and the accuracy is like um, around the middle of zero point 0.5. Loss is high. This is not a promising values actually. We have done. Look at the accuracy, it's like zero point 0.5. Zero point 0.5 is the most worst result that you can obtain, not by means of accuracy, by means of prediction. So for example, if you have an image of person, he's passing in the e-gate of an airport, and you got zero point 0.5, that his name is Ahmed Qusay, zero point 0.5 probability of the prediction result. This is very bad. Did you let him go or keep him, prevent him from traveling? So the 0.5, that means the AI developer is a bad programmer. So this is the aspect. So not promising. You can play with the topology. You can play with the tuning. So you feel free to try. But I say from my experience, I think this is the performance of RNN for this audio data set, not audio, no, audio data set for the current data set. So let us go and continue measuring, plotting. So see, this is the previous plot of CNN. Look what will happen if we plot our RNN. Look the difference. So let me just zoom in, run. You see the plot? Did you see the change in the plot between CNN and RNN? It seems to be that the regularity, the increasing in the curve of accuracy is really better in the aspects of RNN. So this is a comparison. This is a research. This is scientific research if you compare more than one method. Also, I will plot the loss. Look at the loss of CNN, because as you see, I am just copying the common codes, the shared code between CNN and RNN. So let us check. This is the previous code of CNN. I will run. This is, you see, it's dropping. It's good, the news. It's dropping from 1.2 to the 0.6, 0.8, but not promising. Also, you can play and tune around. I will save the model. Check the default library, the default directory. We already have the CNN previous model that we have obtained. and we have already the dataset folder and the untitled, this file, which is the untitled Python file. Let me just open my directory to see a real life generation of the RNN H5 model. So this is our directory. This is our default directory. Actually, one, two, three, three items, and here is one, two, three items. So when I now I will save the model. I'm talking about the RNN, not the CNN. So I just changed this the name of CNN. Instead of CNN, it will be RNN. And now Control Enter. It have been saved, and I think it will not. As you see here, it will quickly appear because the size of CNN is really higher than the RNN. Let us check our directory and talk about sizes. So you see, this is the RNN that generated recently. Now it's recently, it's 26, 27 mega. But in case of CNN, we are talking about 244 mega. And when it's deployed and downloaded, it may be take more size. So, but still, this size of CNN, from my experience, industrial experience, this size is okay. It's perfect because if you want to deploy it on like Raspberry Pi 5 or another environment, hardware environment, it's accepted. If you exceed the 1 giga, you are entering the critical area of deployment of your model. Okay, so everything is fine, and now we're gonna go for the new prediction. Give me a negative audio and give me a positive audio. We are obtaining these files from the hidden folder. We have this folder in the dataset. If you remember, open the dataset. We have a prediction clips. These clips are hide from the neural net in both types, CNN and RNN. So I will take this one and this one negative and one positive. It is in the prediction eclipse. So if you check the path, prediction eclipse. So this is a new, and we will check the negative, then we will check the positive and run this cell. Okay, and we need, since we have now the negative, I will copy the path. I will start with the negative instead of positive. Control V, because this is a raw audio. It need to pass through the 4 stages of audio processing of load, Fourier, and decibel. So I will start with the negative. Don't forget. So we're supposed to get something 0 or close to 0. Run. So we have processed our uh, uh, raw audio, and the name is data. So data is the raw audio, but it's still 3 stages rather than 4. Check the shape. It's 2 dimension. We need to expand the shape into 4 dimensions. So this is expand dim using TensorFlow. Run. Check the new dimension. It's okay, 3 dimensions. So now we can just convert it into tensor as we have done before. Everything is fine. It's the time of truth. So instead of CNN, I will go for RNN. Okay, load. It's loaded with the name of model. Now it's the time of prediction. If you remember, this was the prediction of CNN of positive file. Now we are doing RNN but negative file. We got 0.5. The worst result of a prediction may AI people or engineers or professors obtained is around 0.5 because there is no decision to take. He is a criminal or innocent. Is he positive or negative? Is he a COVID infected or not? I don't know. So this is actually what happened when we try to predict a negative. It should be 0 and around. Let's go to the positive. This is a positive. Control V. Process the positive file. Okay. Check the shape. Expand shape. Check the shape after expansion. Convert to tensor. Load the RNN model. Make a prediction. of positive. Also, we are playing around zero point 0.5. It seemed to be that CNN is better than RNN. That's what the basic inspection saying. But you need to go and inspect all these hidden hidden in the prediction clips. Do prediction for all on both CNN and RNN. And again, 10 clips is not enough. But I am just saying indicators. Thank you.